Hello, everybody. Welcome to the Godot workshop. Today's the 23rd of April, and we'll be showing what Godot is, why you might want to use it over other engines, and we'll try to make a sample project with it. So to begin, what is Godot? It's a free and open source game engine that has 2D and 3D support. The website is godotengine.org. And let's go over some of the what you will need for this workshop. So I will post these links in the Zoom chat, but you're going to want to download the engine on godotengine.org. So let's go over on the Godot engine website what specifically you need to download. So if we could load this up here, you'll see the newest version released just a couple days ago, right after the other video went up actually, is Godot 3.3. And we're going to want to get the standard version of Godot for this. This tutorial we'll be working on today will be focused on a language called GDScript. It is essentially the main language of Godot. It is very similar to Python, and it's used for making scripts for all the scripting you need to do in the game. However, there's also a mono version that has C# support for anybody familiar with Unity, which we have mostly been using in the club so far. And if you'd like to use this, keep in mind our instructions will not be for C#. However, if anyone following along has any questions, feel free to ask me. If you're watching this on the YouTube channel, you can contact me. I'm Jordan in the Pomona Discord, and I could help you out if need be, but it's probably best if you just do GDScript, because I'm still learning a lot of things about how mono works or C# works in Godot myself. Now, not only that, but you will want to download export templates. We'll be using the standard version of Godot, so you should download the standard templates, export templates for Godot. So, and if you're using mono, you'd be using the mono version instead, but let's focus on standard for now. So here are some examples of some games made in Godot. This is just mentioned in the Godot website, and these two are still not yet out, but if you're curious, these are some two up-and-coming games in the next year that are gonna use a Godot engine. The first on the left is X Zodiac, which is kind of like it's very similar to Star Fox, the first Star Fox, and it uses the 3D engine, set to come out later this year, and another one called Helms of Fury, which is set to come out next year in the spring. Let's go over some of the positives and negatives of Godot. One of the positives, its essentially main selling point, so to speak, although it's free, is that it's free software. It is licensed under the MIT license, which is a free and open source license that essentially allows anybody who uses allows anybody to use the project in whatever way they want. They can modify the source code. They could even use it for commercial projects if they want to. And as such, there are no fees. It's not like Unity or Unreal, for example, where you had to pay fees for if you gross a certain amount for your game. It's not like Game Maker Studio where you have to pay like an upfront fee for it. No, it's just completely free. And it's also open source, which means if you want to add something to it, if you want to contribute to its development or change some way it works, either for your own personal use or to commit to upstream, you could do that. So another another aspect of Godot that's interesting is it has 2D and 3D capabilities, but its 2D is real, actual pixel-based 2D. It differs from Unity in this sense because Unity essentially it's like fake 2D. If you're familiar with let's say Mr. Game & Watch in the Super Smash Brothers game, how he's like actually a 3D model that's made to look like a sprite. From what I understand, it kind of works like that. But Godot, in a sense, is more similar to Game Maker Studio. It's actual 2D pixel-based. From my understanding, it kind of lends itself to work with pixel-based, like pixel art games, pretty nicely in that sense. Let's go on to the cross-platform support. It works pretty well with other platforms. I'm mostly a Linux user, and from all of the engines I've used, I could say that the editor support in Linux, it just feels much nicer to use than, say, Unity, which oftentimes completely crashes for me. And Unreal, although Unreal is good, you have to build it from source to use it on Linux. So that in and of itself is already like a big barrier to entry, but I feel like it works really well with other platforms, whereas the other two are very, very Windows focused. I'm not sure any of you use Macs, but you could also use Godot on Mac, and I've heard it works pretty well for that too. And you could also export to many different platforms, as you could see here. You have Android, iOS, mobile, you have web, HTML5, and then of course you have Mac OS, Linux, Windows. And not just that, but also another sort of Linuxy operating system called BSD. It's very obscure, but you could use that. And another nice thing about it is Godot is a very lightweight system, or a very lightweight engine. The actual executable you can get from the website, it's only 86 megabytes, and that's the mono version, which is bigger. So if you want to go for the normal version, it's probably like a little bit under 50 megabytes, but it also performs very well on low end systems. For example, people who use Unity or especially Unreal might run into issues if they have like a lower end system. So that's something that's nice about it. Now, of course, there are downsides to Godot. And the biggest one, what I think, is it has a smaller user base than Unity or Unreal or any of the other bigger engines out there. This is what I consider the biggest downside personally, because this means the jobs in the industry or like indie teams, they're not really going to be looking for Godot experience. In a sense, it's Unity or especially Unreal, or I shouldn't say especially because it just sort of depends on what sort of field you're working in. But from what I understand, those two engines are much more marketable if you put it on, say, your resume or something, if you're looking for, a game dev job. And Godot, since it's more obscure, since it hasn't been around for very long comparatively, it's not as much sought after. And additionally, the smaller user base means the community is not as big as Unity, for example. So there are a lot more tutorials about Unity. While there are still a lot of tutorials on Godot, there are nowhere near as much resources or tutorials as there are for Unity. So in that sense, there might be a bit more of a learning curve to it. Additionally, the 3D engine is not as mature or robust as the aforementioned engines. It's something that kind of came later on in development, and of course, since it's a pretty young engine, all things considered, you can't do as much with it as Unity, and the 3D capabilities are much more impressive on Unity, at least with the stable versions. This is set to change in Godot 4.0. However, 4.0 does not currently have a release date. You could find either unofficial builds of it online or build it from source yourself if you want to try out like the alpha version of 4.0, but there is no foreseen in the future ETA that the developers have announced. So 3D is not, if you're going with the stable version, 3D is not as good right now. And additionally, you can't export directly to consoles if you want to sell your game on consoles. This goes against the free and open source license that it uses because consoles are proprietary and locked down. You can't just do something that's free and open source, like include the proprietary stuff in the free and open source license. The workaround for this is that the two lead developers who made Godot, they have their own companies that specialize in porting Godot games to other consoles. So that's an option, but it is still very much like a cost barrier to entry, and it's not as just quick and simple as I'm going to export for this console that I have a dev kit for. And another one that's kind of a big negative Godot is, although the thing that's cool about Godot is that you have scripting support for other languages such as C#, you have C++ and C for if you use something called GD native. The support, it's not quite as well supported as the GD scripting language that is a part of Godot. So autocomplete, for example, only works with GD script. I've done like quite a bit of scripting in C# in Godot, and it doesn't autocomplete for you. There aren't very many tutorials. There are very little tutorials available for C# support. There is a website called Godot Sharp that explains the Godot API in C# and essentially what sort of things you could do in GD script. It'll explain that, but in C# instead. But aside from that, there are very, very, very few resources I've personally been able to find that talk about C# and Godot. And if you're interested in using the C++ capabilities with Godot's GD native feature, which essentially, like, to explain what GD native is, it kind of like you have other languages that you could use. Most of them are community supported. that you could write scripts in for high performance, and GD Native translates that to something that Godot could use. So for example, this exists for Rust, this exists for Python, and there are some things you could read up on in the Godot website's documentation that explains what this is for. But however, there are less resources for it, and it's a very small community, a very small subset of users that uses this feature, all things considered. The only two officially supported languages for GD Native are C++ and C, and even then, there are like very few amount of tutorials for those two things. If anyone else would like to add anything, please go on.
I just wanted to like jump in real quick. So the main reason I had gotten into Godot was because I heard that they had C++ support, and I had actually recently taken a C++ course here at Cal Poly. So I was like, oh, I'll go ahead and apply my C++ knowledge to Godot. But just exactly like what Jordan said, it's very hard to find resources or tutorials of how to start coding in C++ in Godot. So which is why I eventually started doing it in GDScript, because that's most of the tutorials are in GDScript. A lot of the documentation is in GDScript, and again, the autocomplete supports the autocomplete in the engine for the scripting. It supports GDScript. It just heavily in favor of coding in GDScript for Godot. So unfortunately, yeah, exactly what Jordan said. There is very few support or resources for other languages.
Yeah, thanks for adding on to that and sharing your experiences with it. Anyways, here's a video that Celine shared a while back that we'd like to show for the purpose of this workshop. It's called the Godot Engine Explained in 5 Minutes.
In this video, you're going to learn what the Godot game engine is and what it can do for you. We'll talk about its pros and cons so you know if it's a good fit for you. Finally, I'll give you some free resources to get started with it. Let's jump right in. Godot is a free and open source, general 2D and 3D game engine. It's a program that allows you to create games or even applications that you can then release on desktop and mobile platforms. You can also make console games with it, although you need strong programming skills or a developer who will port your game for you. A general game engine means that it's packed with features to help people create all kinds of games. You can use it to create an homage to Star Fox like Exodiac, a 2D action-adventure game like Dolphin, a 3D tower defense like TaleQuest, or a beautiful side-scrolling action game like Primal Light. The limits are mostly your skills. Let's now look at the program. Godot comes with a complete editor in which you can design scenes. A scene can be a character, a weapon, an entire level, or your game's main menu, for example. You can do everything with them, including what other engines call nested prefabs. Scenes are trees of nodes. In Godot, nodes are building blocks of your game. Let's take the character we just saw as an example. It's composed of a physics body node, a sprite node, a camera node, an animation player node. Hopefully you can tell what each does from the name. Godot comes with an extensive library of these base nodes that you can compose and combine to create more powerful ones. And that's the core of the tool from a user's perspective. 2D, 3D, UI, you do most things with these nodes in written code, of course. Talking about code, you have two main gameplay programming languages at your disposal. GDScript, Godot's simple domain-specific language, or C#, a popular programming language. If you're a beginner, we recommend you to start with GDScript. That's the simpler of the two. Also note that to use C# in Godot, you need to download the engine's special Mono edition. On top of these two languages, you can also use C and C++ to write high-performance game code without recompiling the engine using GD Native. And there's the visual programming language, VisualScript. It works, but the interface lacks some refinement to be productive at the moment. Let's talk about some of Godot's more prominent pros and cons. This is a subjective list based on my experience. I'll start with limitations or things that can get in the way right now with Godot 3.2. Some specific editors like the tile map or that node-based interface lack maturity and can be a bit unintuitive or get in the way at times. While 3D is pretty easy in Godot, the user experience is way behind an engine like Unreal. Level editing and animation tools aren't fantastic at the moment. For now though, you can use Blender 3D instead to do all that. Godot can import levels designed in Blender directly. There is no market for add-ons and assets. There are still few of them overall, and you get limited support. Godot has a free asset library, and you can find some decent tools there. Still, we're missing something like the Blender market, where creators can get some financial support and maybe donate some of their sales to Godot. Now, here are the aspects I like the most about it. First, there are tons of features for 2D, and this side of the editor keeps getting better. It's really mature at this point. Godot being free and open source software means that you can access the source code, learn from it, and as a professional, you can hire people to fix bugs or add features. We're seeing companies do that more and more. Its domain-specific language, GDScript, has a lightweight syntax, leading to code that's short and easy to read overall. Add-on development is terrific. Godot's editor is implemented in the Godot engine, so you can extend it with the same code you use in your games. You can also run any gameplay code in the editor with its dual mode feature. You can get started fast. Godot is lightweight. It's just a 40 megabytes download for the full editor with no install required. Starting your game is also pretty fast with short compile times. And as it's free and open source software, you also get a lot of people from all around the world fixing bugs and making improvements from which you benefit. With over 1,000 contributors and counting, it's growing fast. Now, Godot is completely free. It just takes a few seconds to download. Well, with my internet, more like a few minutes. But you should try it out to see if you like it. And to do so, here are some great resources. We wrote 2 curated guides with only free educational resources for beginners and professional developers respectively. Here are also 3 tutorial series to get you started. On GDQuest, we have a 5 hours free course, Make Your First 2D Game with Godot. To go a bit further, Heartbeast's Action RPG course takes you through the complete creation of a Zelda-like top-down 2D game. And Kids Can Code makes a wonderful site called Godot Recipes, with short, beginner-friendly tutorials that cover a specific problem and give you an efficient solution. You can find the links to all resources in the description below. If you have more questions about Godot, you can leave a comment below, or join our community on Discord. At GDQuest, we contribute to Godot and teach it. We release our code and tools as free software on GitHub. We have a ton of resources for developers, like our Godot shaders and procedural content generation, or our 2D space game. We're also on Kickstarter at the moment to fund a great new course and more free content for everyone. Check it out if you're interested. As always, stay creative, have fun, let's see one another, I hope, in the next video. Bye.
Okay. So here's a sample project that was made by Sam in the let's open it up. Would anyone else like to demonstrate this, or does anyone want me to demonstrate this?
I can demo it.
All right. You should share it.
All right. Hello, everyone. Okay, so yeah, this is the Penguin Ice game that Sam's worked on. It's kind of similar to some of those Pokemon puzzles, like the Pokemon Ice Gym puzzles that you would see, where you would basically slide across. So, like here, and then, yeah. The goal here is to get all of the coins, and then avoid some of the, like the ice gears right here. So like if you go here, it's gonna get a game over, and then you could try again. And then when you get all the coins, you get a you win, and then yeah.
Yeah, so it's a very simple game that we will be developing today. Using, again, like we mentioned earlier, we're going to be using the Godot engine, and we're going to be coding in GDScript. So I guess we can get started with how that looks. All right, so when you open Godot for the first time, it's going to show this Godot project manager. For today's video, or for today's workshop, we're actually going to be creating a new project. So if you just come over here to the side and you can click new project, Godot requires that you choose an empty folder. So what we're going to do is we're going to hit browse, we're in the documents right now, so we'll just go up a path, and I'm going to go to desktop. I already set up a folder before this workshop. But in any case, if you guys, like, for example, want to create a new folder, you could just create a folder right here, and you could just create it from the project manager itself. Other than that, I already have it prepared for us. So I'm going to go to Godot worksheet, Godot workshop. And as you can see, it's an empty folder. So we're, oopsie. Well, let me go back. Desktop. So it's already an empty folder. So I'm just going to click select this folder. So it's already an empty folder that we can start importing, for example, our assets to, and our scenes and our scripts to. So it's already empty for that. We're just going to go ahead and keep the name as is. I'm just going to call it Godot WS for workshop.
Just a quick question. So
mhm.
I've already gone through the video. So are you going to be reviewing that and then going into, like, should I also be making a new project, or?
This is for people who, for example, haven't seen the new the video yet. So just like a quick, like, here is how you get that. Because we have already, so this is just an example basically. So because we already have that demo from the video, I'm actually going to open it right now. So it's going to be this project right here. So if you remember from the video, we created this we have already created this sort of title screen. It's a very simple title screen. It's really just a title screen. So if you just press play scene, it's just a title screen, and all it does is just type out this text into the debug window right there. So just a quick overview from the video again of what the different tabs in the Godot workspace look like. So we will be mostly working in the scene. So for example, if you would like to create a new scene or a new inherited scene, or if you would like to undo or redo, again, all of the shortcuts are right there as well. The thing that we will be working the most on is on the project settings. If you guys didn't see in the video, we did edit some of these project settings a little bit. For example, if we go down here to, let me find it, to window, we turned off resizable. That way, when you open up the window, you can't resize it for any reason. Also, we changed the stretch mode to 2D because we're working on a 2D game. And we also set the aspect to keep. So usually it's on ignore. For now, we keep it on keep. And usually it's on disabled, but we put it on 2D. So that's sort of the quick things that we do for the that's the quick things that we do in the project settings during the video. This scene tab right here is for your scenes. It also shows you the tree, your node tree. So I have this control node, and it has these child nodes: color rect, texture rect, label, and button. You could go ahead and hide that. That is the main tree. And again, this is how you would access the different nodes in your scene. Just let me know if I'm going a little too fast. I have a tendency of speaking really fast. So in the right-hand side here, if you guys ever click on any of these nodes on the left-hand side, it will show the inspector. You can manipulate any sort of elements or variables in these. For example, in this rect area, in this rect sort of section, you could change its position. So I could move it slightly to the left or right, or I could move it slightly up or down. That's where we will be working with that stuff. Another thing that is important in this right side is this thing called the node section. So in Godot, we take advantage of things called signals. And basically all signals do is every time a node, every time we meet the requirements for any of these signals, for example, one of these signals that we talked about in the video was mouse entered. So every time we hover over this button node, it will emit the signal mouse entered, and that'll basically play a function that we see in this script right here. So when we hover over, or whenever the mouse enters the button, it will trigger this signal. It will emit a signal, which basically triggers this function to print this into the debug window. So that's something in Godot that we will always be taking advantage of, especially when creating our coin items, our coin objects, our the spike ball objects, and so on and so forth. This file system right here is how we will be getting our assets, retrieving our assets. This asset folder is the asset folder I used for the demo. So it's not, obviously it's not the complete assets. So I will actually have to import, and I'll show you guys basically how that works when we start importing things. So let me just show you real quick how to import your assets into your file. So I have this assets folder right here. I actually need to go ahead and open the file where this is located. So I'm gonna have to go through my folder real quick. Don't mind me. I have a lot of folders for everything. So it's actually going to be this folder right here. So this folder, it's called demo. It's the exact same folder that you would find this stuff in. So what we need to do is we need to keep this folder, and then just these assets. Again, these are the assets that we provided for you at the in the Discord channel under the announcements tab. Lawrence was also kind enough to link it as well in the Zoom chat. So and then in the YouTube video, we'll also be providing it in the description. So for anyone who wants to download these assets so we can use them real quick. So I purposefully changed the name of the assets so that when I drag it in here, it doesn't conflict with the other assets that are already here. So, oh, where did he go? Did he go inside? Oh, it basically, it overrode it. So it overrode these assets, but as you can see, we actually have all of these things in here now. So these are the new assets that we imported. Importing assets into Godot is super easy. All you just need to do is what I did there. Just drag your assets folder into the same project folder that we have the Godot project in. So now if I open this, it just exports everything. And now when I look in here, ta-da, all of our assets are right here in the file system. Any confusion about that? So the very first thing we are going to be creating in Godot today is we're going to be working with our player scene today. Or sorry, for right now, we are going to be working on our player scene. So what we need to do is at the top of this tab right here, right where you see this plus sign next to this demo, we can go ahead and click add new scene. And when we select a root node here in our scene tab, we're not going to choose any of these right here because that's whenever you're creating a new scene or whenever you're creating a new object, the main node or the root node needs to be the node that you need for your object. So for example, if we are going to be creating a player node, we are going to be using a kinematic body 2D. Because that is the main node. If we just show right here, actually, if we just go right here, oopsie. If you go right here, this is a kinematic body 2D node. And then if you select it, if you right click on any of the nodes in Godot and you click open documentation, it just basically tells you all of its properties, its methods. It also gives you a short description. So the reason why we use kinematic body 2Ds for player nodes is because it's meant to be user controlled. So it is specifically meant for user input. So this is what we will be using for your body or for the main node for your player. So as you can see here, the the kinematic body 2D or Godot is actually giving us a warning. It's saying that this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. So what we need to do here is just same thing as we did earlier. Just click on this, make sure you have this selected so that when you create a node, it will create a child node of the kinematic body 2D. We can go ahead and click that and just go ahead and search what they said right there, just collision body 2D or collision shape 2D. So that's what we're going to be selecting right there. So when we select that, we still have a warning. The warning is saying a shape must be provided for collision shape 2D to function. Please create a shape resource for it. Easy way to fix that is go over here on the right side to the inspector. If you go over to where it says shape underneath collision shape 2D, it says empty right now. All you need to do is just click on the on this toolbar and then just select which shape. So right now we can't actually choose a shape because we don't know what our player looks like. So a way to add a texture for what the player looks like is to add either a sprite or an animated sprite. Because we are working with a very simple or very basic version of this game, our player is not animated, so they don't have any walking animations. There isn't any jumping animations or anything like that. He just slides across the screen. So we're just going to be importing a sprite node in that case. So if you search up sprite, as you can see, there's two different ones. So animated sprite can hold multiple textures for animation, whereas sprite can only hold one. So we're going to create that as a child. So we have it right there. Even though we created the sprite, we can't see it anywhere. Actually, that's because we haven't applied a texture to it yet. So all we need to do is down here in our file system under player, you could see we have that penguin round PNG. From your file system, just go ahead and drag that over to your texture right here. And there you go. There he is. It's just a cute little penguin circle right there. Now we can easily add our collision shape 2D. So we're actually going to choose a rectangle shape in this case. The reason why we're using a rectangle shape, it's because if you saw in our demo game, moving across the map is a little grid based. The tile maps are grid based. So if we have made our collision shape a circle, for example, there would actually be some problems with the collisions. For example, sometimes the player might accidentally slide off of the grid and basically move diagonally, which is something we don't want to do. We don't want our player to be moving diagonally. So in order to prevent that, we're actually going to be choosing a square shape in this case, or a rectangle shape. So any confusions about what we're doing? Is everyone all good, caught up, and ahead?
Just a question about earlier. You brought up like a help screen. How did you do that?
Yeah, so just select any like node, for example. So example, let's like select this node. If you right click, so you could see like all of the options you could do. If you go to the bottom, it says open documentation. And then it'll basically just show you a description, all of its properties that you would see on like this side, as well as like any methods or signals that they do. Yes. So if you guys have any questions, or if you guys want to work more with with more methods that each node can do, and you want to read up on it, it's easy to read it in browser, so you could just read it from here.
Could I bring up one thing real quick? All right, this is kind of a newbie mistake that got me, but on the left, where you see sprite and collision shape 2D, essentially the order that you see those in is how it's going to be from like top to bottom. So since sprite is like, closer to the mother node or the root node, kinematic by 2D, the collision shape is going to be on top of it. You're going to want to make sure that collision shape on the list is underneath sprite, because otherwise you're not going to see the little hitbox thing, because the sprite will be on top of it. And
yes, so
yeah,
basically what he's describing. So basically, the way Godot draws is layers. It's the closer it is to the root node, the farther down it is in the layer. So if I, for example, drag this sprite over the collision shape, then you can see that the sprite is actually drawn on top of the collision shape. So in game, that doesn't really affect anything, but if you're building the game and you want to very clearly see the collision shape, for example, if I took the collision shape and I made it smaller than the sprite, now I can no longer see the collision shape because it's over it. So you want to make sure that you can see it just like that. So, and there you go. All right. Everyone's all good so far. Okay, great. So the next thing we're going to do is we're actually going to before we do any of this, actually, we are going to go ahead and jump back into our project settings, because there's a very important tab here that we will be using to basically set up the user inputs for our player. And that is going to be the input map right here. So this input map, it already has a bunch of different preset inputs. So it has UI accept, UI select, cancel, so on and so forth. So it's already set. But as you can see, if you scroll all the way down, we actually don't have inputs for player movement. So up, down, left, and right. So we're going to actually have to add that in manually. So the way we do that is you just come here to action, and then you just type in the name of the action you want to do. For example, let's do up. And then you just click enter. And then now you can see at the very bottom, we have created the up input. But we don't have any keys binded to it yet. So the way we do that is we just go over here to this plus button, click on it, and then just go ahead and click key. And then on your keyboard, just click anything. So in this case, I'm going to press W. And I'm also going to add another one, and I'm going to press the up arrow. There you go. And now we're just going to basically do that for all of the rest of our directions. So left, right, and down. Oops.
So then if we were to make this into a full game, would this be something that could be configured then in a menu?
Yes. So I personally don't have I have very limited knowledge on Godot aside from the basics. So, but I am pretty sure that there is actually a node that handles options, and from the options menu you could go ahead and change the keys to other things as well.
I see. Cool.
Yes. All right. So now we have, these are just preset or already defined basically. So now we have all of that set. We can go ahead and just click close. And then now we can go ahead and start working on our player script. So we are going to select the kinematic body 2D because this is what we are going to attach the main script to. And then we are going to press this one right here, this little button right here, which is basically looks like a piece of paper with a plus sign on it. So this basically just means that we are attaching a new or existing script to the selected node. So we can click that. We are going to remember code in GD script. Everything here seems pretty good. The path is correct and everything should be fine. For templates, default has some comments in it. Empty is just, it's basically, excuse me. It's basically just like an empty script, and then no comments. It's basically the default script, but without any of the comments. So, but for now, we're just gonna select the default. We're gonna hit create, and now we have this new script. There are some comments in here if there are any. If you would like to know how to, for example, declare variables, this function is already built into the game, function ready. And this is basically called every time the node enters the scene. We also have a function process delta, and delta is elapsed time time since the previous frame. So it's coded out, but if we want to, we could, it's commented out, so we could just comment it back in right here. So that's all good. So just give me one moment. All right. So we are going to declare some variables here. So we have, for example, var A and var B. We are going to make our own variables. So the first variable we're going to be making is our speed. And for now, we're going to be setting that speed to 70 because our tiles are 70 pixels by 70 pixels. So that's what we'd be working with. So for now, we are setting the character speed equal to 1 tile space. What we can do actually, for example, you set it to 70 and you wanted to change that over the course of the game or over the course of coding, and you didn't want to just always come back to the script to change it manually, we could type in the keyword export. And what that means is now if we come here and we check this side right here, we actually have exported this variable, and now we can just change it to whatever you want to. For example, 140. So export just basically makes it for example, if I removed it and I come back here, export gets removed from this inspector element right here. So if we want to make it an element that we can manipulate in the editor, we could type in the keyword export right there. The next variable we're going to be working with is called velocity. So we're going to do var and we're going to do velocity. what we're going to be setting this to is an object called vector2, and we're going to set its default to 0 and 0. Basically, this just means that we are creating a variable called velocity, which is a vector object where its x and y values start at 0. That's the meaning of what this is. We actually don't need this function ready right here. So we don't need this function ready because we want everything to be handled in a function called physics process delta. So we are going to go ahead and just remove this. Unfortunately, we don't need it. So we are going to be coding in a function called physics process delta. It's a little bit different from process delta in that it involves, like, as the name implies, it involves physics. So an easy way to just amend that is just to do physics. Oops, physics. If I know how to spell physics process delta. There you go. So just amend physics onto the process delta, and now it's officially a physics process delta function. We are going to be using several if statements for the handling the player movement. So the first if statement that we are going to use is if velocity equals vector 2 0 0 0. So the way if statements are written is you make sure you add a colon after the if statement, and then it indents for you automatically. So it's a little different from your typical curly braces that you're used to in other coding languages. So that's definitely something you have to get used to, especially no semicolons here. I know when I first started coding in GDScript, it was a little painful not to put semicolons basically everywhere. But basically all this if statement is telling us is that if our movement is 0 and 0 for either the x-axis or the y-axis, then we can start taking in inputs. So a key function of this penguin ice game, it's an ice sliding puzzle. So if we move in one direction, we will only move in that direction until we are stopped either by a wall, basically, or by other objects such as the spike gearball, which just leads us to a game over. So this basically locks our player movement right here. So if our velocity, what this is saying is if our velocity in either direction, x or y, is 0, then we can go ahead and start taking in user inputs.
I'd also like to say that GDScript is, from what I understand, very syntactically similar to Python in the sense where white space matters. You have tabs to indicate what your where brackets would be in other languages. So if anyone's familiar with Python, I think a lot of the fundamentals would translate over to GDScript. It was modeled after Python.
So now we're actually going to be working with those input buttons that we created earlier. So the function that we want to be calling is called input is action pressed. So we're going to make another if statement. So we're going to say if input. So we're calling an input object dot is action pressed. So as you can see, the autocorrect or not the autocorrect, the autofill will sort of bring all of these for you. So we're going to be going over to is action pressed. So we could press enter. And as you can see, it lists all of the inputs that we had created earlier. So we are going to select left, for example. So if input is action pressed is left, basically all that's saying is if the player presses the left key, we are going to be moving to the left is what we're trying to do right now. So we're going to go ahead and put a colon and hit enter. And then we're going to go ahead and do velocity. If I know how to spell. Velocity equals vector 2. And then we're going to do, actually, oopsie. Because we're working with the X, we're going to work with that first number right there. We're going to do negative speed and 0. So that's what we're setting it to. What we're doing is we're setting the X value of our vector object to equal to negative speed. So whenever we're working towards the left of the X-axis, we're working in negative values. If we're working to the right of the X-axis, we're working with positive values. If we're working up on the Y-axis, we're also working with negative values. And then if we're working down on the axis, we will be working with positive values. Another way to write the script, if you wanted to, you could do velocity dot x. So you're accessing the x component of velocity. You could just set that equal to negative speed. That's another way you could write this code out. So next thing we have to do is just basically copy this script for our other inputs, but just change them a little bit. So just use this. We could fix the spacing a little later. So let me fix the spacing right now. Okay, so we fixed the spacing, but remember we have to change these. So let's, for example, change this into, instead of left, we'll do right. And then instead of negative speed, we'll do positive speed. And again, this is the same thing as saying velocity.x equals speed. Next thing we'll do is instead of left, this will be up. And then instead of this being negative speed, we'll go ahead and set that to 0. And then we'll go ahead and set this to negative speed. And then again, this is the same thing as saying velocity.y equals negative speed. And then lastly, we're going to do down. And then we're going to say set the x to 0 and then set the y to positive speed. And again, same thing as saying velocity.y equals positive speed. So there is actually one more thing that we are going to be adding to this piece of code here before we're finally done. We're going to add a move and slide object or method to this velocity. So we're going to do set velocity equal to move and slide. So basically what move and slide does, if anyone is curious, you could, if you hold control and you hover over any of these objects, it'll bring you back to that documentation we were talking about earlier. So if we look in move and slide, it is a vector 2D, it's a vector 2 method, moves body along the vector. If the body collides with another, it will slide along the other body rather than stop immediately. It will blah, blah, blah. Yes. So basically this is just all explaining the methods. Explaining the different methods if anyone is curious as what they do. So we'll go ahead and select move and slide. So basically all this does is if it collides with something or if it stops moving, it will slide for a little bit and then it will go back to stopping speed. So it needs velocity. And then we could go type in vector 2 dot up. All right. And then after this, that is basically the whole player script that we need for this game. All right, great. So all we need to do now is just hit Control S to save. We're going to go ahead and call this player, hit save. And now this is our player script. I'll actually go ahead and call this player as well. All right, awesome. So unfortunately, if we press play scene, there's no way for us to test this. Well, there is a way for us to test this. As you can see, that's a little guy. He's moving very, very slowly off into a different direction that we can't see because it's off screen. So what we do need to do now is we need to create a level for this character for us to be able to see this character. So we're going to go ahead and create a new scene. And we are going to start with a node 2D scene. So just the basic node 2D scene. This is because we are working with a level and we need a root node that basically inherits all of the, that is basically the parent node of all of the node 2G objects because we are working with most of them today.
Just to make sure, this is a normal node 2D, right?
Yes, it is a normal node 2D. So that's actually a good point. So if you look here, all of the different nodes are actually color coded. So anything that is a child of a node 2D is going to be colored blue, and anything that is a child of the node 3D is going to be colored red. So that's a very important distinction. Also, anything that is considered control or part of the UI or anything like that, they're all going to be colored green. So just as a way to differentiate, making sure that you guys are selecting the correct types of nodes there. Okay, so now we're going to go ahead and create our node 2D. The very first thing we're going to do is we need to create a backdrop for our player to play in. So the way that we do that is we're going to go ahead and create a tile map. So we're going to go select node 2D and we're going to press add node and we're going to select tile map. we're going to go to tile map and we're going to double click. And as you can see, now we could see this sort of grid that appears on our screen right here. But the thing is, we don't have any tile sets to start creating our level with. So what we're going to do is we're going to where it says tile set here on the right, we're going to select this and we're going to hit new tile set. So we're going to create a new tile set for us to start putting our tiles in. As you can see, I can now hover over this, but I don't have any tiles to place down because we haven't made them yet. The way you make tiles in your tile set is you just click on tile set again, and it'll bring up here on the bottom, it'll bring up the tile set inspector. So all you need to do is write in our assets folder where it says tiles. We have two types of tiles here. You can go ahead, hold shift to select both of them, and you can just go ahead and drag them to the left-hand side right here, this dark square that's right here. And when you do, they now appear, and now we can start creating a tile. So what we're going to do, let's go ahead and select the ice PNG right now. So the ice PNG or the ice tile is going to be what our player slides on. So anytime our player is on the ice, it will go ahead and slide on top of it. And again, remember here in our 2D players, in our player script, the sliding mechanic is handled in the input in the player script. So there really isn't actually anything special that we have to do with this tile set. Oops, let me bring it back up. So click on tile set. There you go. Oh, I actually need to bring it back. All right. So there isn't anything special we need to do about this tile set. What we do need to do is, in order to put this into our level, we need to create it as a tile. So what we're going to do on the top of this inspector right here, we are going to click new single tile, this yellow button that appears right here. When we click that, we can go ahead and select the region that is going to show up on our tile map when we create it. So for an easier way to select this, because if you do this, you could just like select that, and that's kind of wonky. It's a little wonky. So what you can do is you can select this, so you can enable snapping, and now you can select which tiles you want to show. Now, I mentioned a little earlier that all of these tiles are 70 pixels by 70 pixels. The default for Godot is that it assumes that all tile sets are 64 by 64. That's why you can see, if I zoom in a little, that's why if you look here, we're actually not covering the whole tile for this tile set. So what we need to do to amend this is over here on the left side. If you select snap options for step, we're actually going to change this to 70 by 70. So that's going to go ahead and now select the whole tile. So now if we just click on it again, it now selects the whole tile.
That
Any question?
isn't there on my end.
So what you need to do in order for this to pop up is you need to select a region first. So let me delete this real quick. So when you click new single tile, you need to select a region first, or even part of your region, in order for that to pop up on the side there.
Oh, okay.
Yeah, okay. I had a problem with that too when I first started making a game. I was following a tutorial and it mentioned that if you want to change the steps, you could go check on the right side, and I couldn't find it. I was like really confused. I thought I had a different version of Godot or something, but no, you just need to make sure you select a region first, and then you could go ahead and access the snapping options. It's a little weird. You'd think you could access the snapping options and then, work on selecting your tile, but that's how it is. That's actually it for this tile. So the player is going to appear on top of this tile. So we actually don't want the player to collide at all with this tile when we put it in the map. So all we're going to do is select that region. All that means is that when we add it on our tile map, that is what our player that's what our player will see. So for example, if I select tile map, as you can see, this is sort of like a palette where you could select your different tiles. I can now start building my tiles right here. Another thing to note, again, everything in Godot for the tile mapping is set to 64 by 64. And as you can see here, we're actually clipping some of our tile into other cells. These are called cells, these little squares here. So again, another way to fix that is on the left-hand side or the right-hand side on the inspector under cell, just change it back to 70 by 70. And that should fix the spacing. Again, it's a little weird. I'm not exactly sure why these assets are in 70 by 70. But we can start a way you can paint on your little on your scene is you could just hold left click and drag to paint on your scene. And then if you, for example, making a mistake, like right here, you can go ahead and hold right click to erase. Another thing to note, I think I forgot to mention it earlier. If you use middle mouse button or if you click on your scroll wheel, you can drag your scene around.
Also, for people like me who have broken middle mouse buttons, you can hold down space and then left.
Ooh, I didn't know that actually. Also, I feel bad about your middle mouse button.
They all break. I don't know why.
Okay, something that is important to note though. Pay attention if you look really closely. I'm not sure how well it will show up on Zoom, but there's actually a really thin blue line that you could see on the screen right there. What that blue line represents is it represents our viewport. So if I, for example, hit play scene right here, oh, the scene has never been saved. So let's go ahead. Let me name this level real quick and let me go ahead and save it. That way it saves as level. There we go. So if I click play scene right here, what I see in this viewport in this window is what is defined within these blue lines. So for example, let's see. Let me stop it real quick. So let's erase some of this and let me just like draw out the word hi or hello. Let's just do hi. So let's say I write this word hi right here. If I play the scene, I actually won't be seeing it, as you can see right there. It's because it's not in the viewport that is defined by those blue lines right there. And a way that we can adjust the size of that display port is in our project settings. So if we go to project settings, go back to general from input map, and if we go to scroll down a little bit, if we go to display window, oh, we're actually already here. If you go to display window and width and height, you could go ahead and change that. For this game, we actually are going to be changing this again because our game is in 70 by 70 pixels for the tile map. We are going to be changing this a little bit. So instead of 1024, we're going to change that to 1050. And then instead of 600, we're going to change that to 700. So these are all just in multiples of 70s, just so it's easier to set up this tile map. So I'll just go ahead and click close. And as you can see, it actually changed the size of these blue lines a little bit. So now you can see it's actually aligned. And if I press play scene, I could see a little bit more of that hi that I wrote at the bottom there. All right, I'm going to go ahead and just paint the rest of this. So now we're going to add in the part of the level, the tile of the level that the player can collide with. So we're going to take this snow PNG. We're going to drag it to that blue square right there. We're going to do the same thing that we did with the ice PNG. So just click new single tile. We're going to go ahead and select this whole region. Now, the next thing we need to do is we need to set up the collision for this tile. So if we go to this collision tab, we're going to select this new rectangle, and from the top of this square, you're going to drag it all the way down to the bottom. And now it creates this collision. And that's basically all you need to do just to create that collision. All right, so now that we have that set up, if we go back to our thing and we select this snow, we can go ahead and draw, for example, our snow right here. Let me just, as an example, I'm going to go ahead and leave this open-ended just to see how the player basically interacts with these collisions. So now you might be... Oh, yeah.
Sorry, I'm not able to get the collision thing to work for some reason.
Okay, so if we're here, let me select tile map, tile set. So did you go to the collision tab?
Yeah, okay. I think I needed to pick the rectangle tool.
Yeah, you need to pick the rectangle. I'm not sure why. Oh, okay, yeah. So yeah, you need to click the rectangle, the square option, and then click and drag from the corners to the opposite corner, and that should select the whole thing.
Yeah, okay. I missed that part. Sorry.
No, you're good. All right. So now you might be asking, we have a really basic level set up. So now how do I add on our player? We have our player here as a separate scene. So how do we add him into our current scene? A way to do that is if you go to level, make sure you select the root node. So we select this node TD called level. Instead of pressing this button, we're going to press this button. So this button adds a node to our scene. This is going to add a scene to our scene and add it as a node. So when we click that, it's going to ask us which one do we want to connect. We're going to go ahead and connect the player.tscn, and we're going to select open. And now you can see our player is here and he's happy. He's really, really big. A way that we could change that is if we go to the player scene, we could just go ahead and change his scale. He's a bit big. He's a big boy. If we go here, if we just go to transform real quick, I think if we change his scale to 0.4 and 0.4. Oh, I made him a little too small. An important thing to note, anytime you change something in a scene, for example, I changed the scale of this player model, right, on the scene itself. If you go back to this scene, I think if I... Oh, is he not the same size? I think if I bring him back... Oh, he's the same size. Well...
Oh, I think you need to save it.
Oh, I didn't save it. You're right. So if I save it, there you go. Now he should shrink to the appropriate size. So yeah, anytime you change it in a scene and that scene appears in another scene, if you save it, it will change it on the other scene as well. So that the reason why we, for example, create coins as a separate scene as opposed to just putting it straight into the game. It's because if we want to have multiple coins in the same scene and we want to change a bit of the coin, we don't want to go into every single coin instance and change it manually. If we just create it as a scene and import it, if we just change it on the scene, it will change it for all of the coins. So that's sort of why we do it that way. So he's still a little bit big, but for now we're gonna go ahead and test this scene so we could see how he collides with these walls. So we start the scene. If you move to the left, he moves really slowly. We could adjust that later. You can see he's not actually colliding with the ice at all because that's the ice. The ice is more as a background to let the player know that if he's on the ice, he slides on it. So he collides with that wall right there, that wall of snow. So now we're just going to let him, yep. Because there is no wall there, he is just going to slide infinitely out of the viewport, and now we can no longer see him. Now he's just gone forever. And there's no way for us to bring him back because, remember, in the script, we made it so that he can only move if his velocity in the X and Y axis is 0. So he's just moving infinitely now. He's just gone. All right. So we can go ahead, now that we have this, we could just start building our basic levels. So I'm just going to go ahead and recreate the exact same level that is in our, that is in the demo that I made. It's because I'm not original. It's also because I'm actually not very good at level design. So I had my friend who is really good at level design the level for me. So I'm just going to go ahead and copy what he did basically. Yeah, my friend's pretty good at designing levels. He's a little crazy. So it's going to be like this. You guys can design your own levels if you want, if you guys have your own ideas for how to make an ice level. For now, I'm just going to recreate the exact same one that we see in the demo.
So if we wanted to get the penguin to be the size of one single tile, is there a way we could easily like lock it into that size?
Yes. So I think I didn't make him the correct size earlier when I changed his scale. I think I have to change his scale a little bit more. So the best way to do it, again, unfortunately, this penguin is also not exactly divisible by 70. It's not his dimensions are not multiples of 70 for some reason. Again, no idea why all of the assets are basically different aspects of each other. So his scale is 0.25. So just change the scale from 0.4 to 0.25. So he should be around the same size. Unfortunately, you would have to eyeball it a little bit. I think now, there you go. He is around the same size as all these tiles here. Yep, he's around the same size.
Okay,
We're going to go ahead and drag him. We're going to go ahead and drag him to this thing right here. You do have to be a bit careful with the collision box. So a little thing to know about the collision box is that the size really matters. It's actually a little better to have a smaller hitbox than to have a bigger hitbox. Because if you have way too big of a hitbox, he's just gonna, let's just do it as an example. If I make his hitbox a little too big, for example, And if we play this game, I don't think I can move him at all. Yes, I can't move him at all because he's just colliding with the wall because of his hitbox. Even if like you could see he's not actually inside of any of the walls there. Even if we do that, he's just colliding with the walls. I can't move him at all because he's colliding with them. So it's always better to have a smaller hitbox. So if I change this hitbox, I could just make it a little smaller. So you could just judge it by the size of the sprite here. So a little less than the actual roundness of the sprite. So now if I start it and he's right there, just make sure his hitbox isn't colliding with anything. Now if I start the game, he should be able to... Oh, hitbox is still a little too big. He's a little too thick. There you go. So make sure his hitbox is a little smaller. Now he can move normally. Again, he moves a little too slow. We could just change that real quick. Remember we exported that var, so we could go ahead and change it. I'll go ahead and make it 280, so he's 4 times as fast. So if I play the scene, now he moves pretty fast. Look at him go. All right. Honestly, you could just stop it right there and be like, yep, this is the game, but we do need an objective to this game. And the objective that we have is that we want the penguin to collect 3 coins, and then that will be the main objective. So we're actually going to go ahead and start making that that coin scene. So what we're going to do is we're going to go ahead and create another scene. Again, instead of these root scenes that they provide for us here, we're going to go ahead and click other node, and we're actually going to create something called an area 2D. We're going to create that, and we're going to just go ahead and name this coin real quick. So if you're interested in the documentation for Area 2D, go ahead, right click it, open the documentation. So it's a 2D area that detects collision shapes, nodes overlapping, entering or exiting, can also alter or override local physics parameters, gravity, and damping. Right?
I have a question about the coin, if that's all right.
Yeah.
I noticed you put it in lowercase for coin. Is there like a kind of, what do you call it? Expectation? I forget what the word is, for capitalization for scenes.
I'm not exactly sure. What I usually do when I code in Godot is anytime it's a big main level, for example, anytime it's a level or it's like its own scene where that holds other scenes, I make that capitalized. And anytime it's a scene that I add on to other scenes, then I make it lowercase. For example, these players are lowercase. And that's because if I, for example, wanted to add another player, let's say if I added another player, it automatically says player 2, for example. So let's just delete them real quick.
All right, thanks.
It's the same thing for coins because we're adding more coins to our scene. It'll add it as coin 1, coin 2, coin 3. I don't know exactly if there's a syntax or like a capitalization expectation for anything. I haven't run into anything in any tutorials. This is just so far how I've been naming it. I think it's your own personal choice.
Okay, thanks for sharing.
Yeah. Sorry, I didn't have like an actual answer.
Oh, that's not a problem at all. Like what's it called? I'm glad to hear the rationale behind these things.
All right. So now that we have this root node set up, it's going to give us that same warning from earlier. It doesn't have a collision shape, so we need to add that. Let's go ahead. Any recent nodes that you have used recently, you could just go ahead and click it from here instead of just switching it up. So we recently used the collision shape 2D, so we could just go ahead and add that on there. In this case, our coins, if you noticed in the demo, our coins are actually animated. So they have their own little animated sprite. The way that we do that is we're going to go search up animated sprite, and we're going to go select the blue one again, because the blue one is always for the 2D nodes. So we're going to create that. Make sure you bring it above collision shape on the tree right here so that it draws underneath the collision shape. So here's the warning that it says right here. A sprite frame resource must be created or set in the frames property in order for animated sprite to display frames. In order to amend that warning, just go over here to the right side where it says animated sprite and it says empty. Go ahead and click on it and just click new sprite frames. It's sort of similar to how we made this tile map earlier where we did tile set and we did new tile set. So if we come here, as you can see, it actually appears here on the bottom, again, in the bottom inspector. So we're going to go ahead and add those animation frames. So we have the default right here. Go ahead and select that, the default. You could change the name into whatever, but for now, we'll just keep it to default. If you wanted to add more animations, like if there were different animations for anything, you could click this and you could select a new animation. We only have the default spinning animation, so we could just go ahead and just keep the default right there. So we're going to go ahead to default. We're going to go to items and in our assets folder. So we have coins 1, 2, 3, and 4. So we're going to hit shift, select all of it, and just go ahead and drag it to animation frames right here. So, all right. And now if we click playing, it will show us the animation. So if you wanted this animation to look a little smoother, we could just duplicate some of these frames here. So I'll go ahead and drag 3 to the end, so it's a little smoother, and I'll also drag 1 to the end. So now this animation looks a little smoother. Also, you could see that the animation is actually kind of slow. If it's slower than what you would like, you could go ahead and change it in the speed right here in the FPS. We could, for example, let's do 10 FPS. I think that's a pretty good speed for this. So spinning at 10 frames a second. So if you want to be able to see the animation, you can go ahead and click playing. It will go ahead and play it in the scene, and also when you add it onto the next scene. So I'm gonna hit save real quick. Make sure it's called coin.tscn and then hit save. Next is our collision shape 2D. So we're going to use a circle shape, and we're going to do the same thing. We're just going to drag. We're going to eyeball it a little bit, just see. That's around the same size as the coin, so we're going to go ahead and do that. So we're going to go ahead and hit save one more time. So now we have this animated sprite, and now we have this collision shape 2D. Now, the thing is, we have this now, but we don't have any way for the player to collect these just yet. So for example, if I added this coin into the scene, the coin is still a little bit big, but we'll change that later. So let's say I add this coin to the scene. If I play it and I go into it, there's no indication that I've collected it, or there's no indication that I've entered its body or anything. So we're going to go ahead and implement that into our code. So what we're going to do is we're going to go to coin, and we're going to create a new script, just like how we did it earlier. I'm going to press this button right here. I'm going to go ahead and choose no comments, so that it'll give me the default, but just without any of the comments. So I'll hit create, and there you go. So it's just basically the same as the default, but I don't have any comments here. It just looks a little neater. So we're actually going to create a special kind of variable called a signal. So remember when we were talking about signals earlier, when we were doing it in the video, for the YouTube video for the demo, we were talking about signals that are right here. You could actually create your own signals, signals the same way you could create your own properties. For example, oh, did I delete him? Oops, not that. I wanted to open player again. We can create our own signals the same way we can create our own variables by exporting them. So the way that we do that is if we come here, above our functions, if we type in signal, and let's just call this collected for now. So what this does is it creates a signal called collected. So if I come here and we come to node, in coin.gd, we see we have created our own signal right here. So very, very useful. So we're going to come here. We actually don't need this function ready at all. What we do need is we need a function that is called when a signal is emitted. And one of the signals that we need to emit is called the body entered. And the body entered signal is actually a signal of the area 2D node. It's going to be this one right here. So if we read it real quick, it's emitted when a physics body enters the collision shape or the area that is defined by the collision shape. So if we double click that, it's going to ask us to connect the signal to a script. So the script is that we've created is on the coin file. So we're just going to go ahead and connect that. So now we have this function that we have created here. So this function, like it said earlier, this function will be called every time a body has entered. A physics body has entered the area 2D space. So if we wanted to sort of test that out, what we could do is we could just do print Just let's do, for example, hello world, because we love hello world. Let's go ahead and save that. So now if we play this level right here, if we play this level and we have our player enter the body, it prints out hello world. So that's basically the function of the body entered function. So every time this physics body, the kinematic body 2D of the player enters the area 2D, it will call that body entered function. So what we need to do is we need to make it so that the player collects this coin. So what we're going to do, instead of print hello world, we are actually going to go ahead and emit that signal. Emit signal. And then we're going to emit the signal collected, which is the signal that we created right here. Basically, what that means is every time this function is called, it will emit also this signal that we created here. We will get to this signal in a little bit. But for now, that's what we'll have. Another thing that we will do is we will actually go ahead and do queue free. Basically, what queue free does, if we hit control and we click on it, it queues a node for deletion at the end of the current frame. When deleted, all of its child nodes will be deleted as well. This method ensures it's safe to delete the node, contrary to object.free. Use object that is queued for deletion to check whether a node will be deleted at the end of the frame. So there's just some documentation right here. So now if we play this scene and we collide with it, it just disappears. So in the player's minds, we have essentially collected the coin, but we actually, in the code, we actually haven't accounted for that yet. So you might be asking yourself, so how will the player know that we have collected a coin? Or how will the player know how many coins we have collected? The way that we do that is with a heads up display. So what we're going to do in this level section, we're going to go ahead in level, we're going to add a special type of node. We are going to add a canvas layer. Oops, typing in the wrong spot. Canvas layer. We're going to go ahead and add the canvas layer. Again, if you want to read what this does, go ahead, open documentation. A canvas nodes that are direct or indirect children of a canvas layer will be joined on that layer. The most important thing right here is this part that says this is very useful for heads up displays or backgrounds. So we're in this case, we're going to be using this for a heads up display. We're going to double click it and we're going to just call this HUD real quick, just so we have clarification. Now, there are a few nodes that we need as a child of this HUD. The first node that we need is a panel. We're going to go here. So having this selected, we're going to add another node and we're going to go ahead and call this panel. So a panel is basically a container. It also works as a background to hold other things. So for now, we just have this kind of weird black background. If we want to change what that looks like, we could go here to custom styles, and under panel, we could select new style blocks flat. New style box flat. And when we click on that property, we could go ahead and change the color of it. Let's change it to color blue, like this really nice blue, so that it matches sort of the color scheme of our game right here. So we have this really nice little blue. Okay. Let's say you didn't like how sharp these corners were on your panel. We could go ahead and change that. If we go to corner radius, we could just set those corner radiuses to 20, for example. It just basically rounds out the corners, so it looks a little nicer. I personally like doing this. You don't have to do it, but I like doing it just because it looks nice. The next thing we're going to add is we're actually going to add a texture, a picture. So what we're going to do, we're going to add a picture of our coin. What we're going to do here is we're selecting the HUD node again. We're going to add a child and we're going to go search for texture. Texture rect. So this is a control for drawing textures. So textures are basically the same thing as sprites, but instead of it being a sprite, it's just a simple picture. So in this texture box right here, we're just going to go ahead and drag coin 1, the first coin. There we go. If you notice, if you try to click and drag to expand this, it won't expand at all. The reason why is because you need to make sure that this expand property is turned on. That way you could go ahead and change the size. So if we do this, go ahead and select that. So now we have that background and now we have that coin. Now the next thing we're going to do is we're going to add 2 child nodes called a label node. So if I select HUD, we're gonna do label. So label displays a plain text in a line or wrapped in a triangle. We could also use that to display how many coins we have. So we're gonna go ahead and hit create. And then I'm actually just gonna do Control D to duplicate and create another one. So we're gonna call this one X, and then we're just gonna call this number sign. So if we come here, X, if you want to set the what this text says, just in this text bubble, the text property, just type whatever you want. For now, we're gonna hit X because that's what we wanted to say. And for this, we're gonna go ahead and hit these pound signs right here. So let's just go ahead. It looks really ugly for now, but this is just to sort of set up how we will see, how we will know what has been collected. So we are going to go ahead and add a script file to this HUD, node. Basically, what this script does on the HUD is it's going to keep track of how many coins the player has collected. So remember that collected signal that we created earlier, this collected signal will be transmitted to the script for the HUD. So we're going to go ahead and select HUD and create that script node right there. So canvas layer, everything is right there. So we are going to create a variable. The variable we're going to create is called var coins. This is again going to keep track of how many coins the player has collected. In this ready function, we are going to call the child node. So the way you call child nodes and you call their functions is you use the $sign. And then you type in the name of the child node. So the name of the child node we want to access the methods of is called pound. So we're going to just do pound. I just realized I made a mistake. I should call this something else instead of pound. So I'll just call it coins. And to avoid confusion, I'll just do capital coins just to avoid confusion. So I'll do capital coins. So let's just go back. I made a mistake of calling it pound because that's how you do comments in Godot. So now we have.
Wait, so I'm wondering, do you know if the normal, like, since this is based on Python, would the normal naming scheme be with underscores or would it be camel casing?
Again, I'm not exactly sure. A lot of the knowledge that I'm displaying here is knowledge that I gained from watching a lot of tutorial videos. I specifically watched tutorial videos by this guy called Born CG. I'll actually go ahead and type his name in the chat. If you guys are ever interested in Godot and want to find some really good tutorials, his tutorials are very recent and he's very good at teaching how to work with Godot and things like that. So when I was watching his videos, it didn't seem like he had a specific naming scheme that was like obvious. So again, you can name it however you would like to for now, because again, I'm not exactly sure if there's a specific naming scheme that GD script has.
I think I could answer Daniel's question a little bit.
Mhm.
I don't know if okay, so I'm not entirely sure, but I do remember somewhere on the Godot docs, there is something that talks about the sort of naming conventions things go by. And one of the things I do know is functions and variables, just to use within scripts and whatnot, they all use snake case. Also, snake case sucks. I hate it. And then what else is there? But then I think, what are these called? Nodes and whatnot. And in this case, all of these things on the left, sorry, my mind's blanking. I noticed like some of them, you see panel, texture rect, those use Pascal case. And if I'm not mistaken, in the docs, it does mention that these things do use Pascal case. But yeah, I hope that answers your question a little bit.
Yeah, just basically general like style guide, more out of curiosity than anything. Okay, thank you.
All right. So the way you access the child of a node is to use the $sign. So we're going to go ahead and access the child node called coins. So $coins, and then we're going to go ahead and do text. So we're basically changing the text of the of coins, and we're going to change it from what it says right now. So remember, it says right now, it says pound. We're going to go change that instead to a string that contains the amount of coins that we have. So actually, it's supposed to be capital string. There we go. So basically what that does is when you ready this function, or when you call the ready function, it will change the text to whatever the value of coins is. All right. Now, the next function that we need here actually is going to be that collected signal we created earlier. So we have this instance of the coin scene right here. So what we're going to do is on the right hand side, we're going to go to we're going to go ahead and go to node, and we're going to go to collected. We're going to double click that, and we're going to connect that signal to the HUD method. So coin collected, that seems like a good enough name. We're going to hit connect, and now we have that here. So this little symbol that you see right here, it means that this is a signal that is being connected from somewhere. In this function, we're going to go ahead and create this code. We're going to do coins plus equals 1. And then we're going to call the ready function. Ready function. So basically, remember when we created this coin signal right here, whenever a physics body enters the area 2D, it will emit the signal collected. And when it emits the signal collected, it's going to go to the HUD right here, and it's going to call this function on coin collected. It will go ahead and add 1 to the total of coins, and then it will go ahead and call the ready function, which will go ahead and display this. So if we want to test what that looks like real quick, I'm going to go ahead and collect that coin, and you see it changes from 0 to 1. All right. Another thing we could add here is we could add a condition. So for this game, we say that if we collect 3 coins, you basically win the game. So if you want to add that to this function right here, you can. So if you do if coins equals 3, do colon, then you would do get underscore tree, parentheses, change scene. And then we don't really have a, let's go ahead and change it to the demo. So the demo scene, if we remember, is just this really simple 2D screen right here. If we want, we could actually go ahead and change this so that when you hit play, it will actually bring you to this level scene. The way that we do that is we go to the script. Instead of doing on button pressed, instead of printing that, we're going to go ahead and do the same script that we did earlier. So we're going to do get tree dot change scene, and then we're going to go change it to level. So get tree, again, if you're curious about any of this documentation or what these methods do, you could go ahead, hold control and just hover over it, click on it, and it returns the scene tree that contains this node. So because this control is in this tree right here, this tree, it will go ahead and go change the scene to this level. So actually, if we play this and we hit play, it should bring us to this level. Awesome. And then now if we do this, we actually only have 1 coin. Let's go ahead and add more coins just so we could meet that condition. So I'll just go ahead and duplicate a bunch of these coins and add them somewhere. Let's just add all of them in this one line just to make it a little easier. So if we collect this coin, and then if we go up and collect all these coins, hey, now you're back at the scene and you could go ahead and play the game again. All right, so let's go ahead and modify our HUD a little bit. As you can see, our HUD is a little, it doesn't look very good, if I do say so myself. So the way that we could change this is we could add our own custom fonts to this. So let's go ahead and go to our labels. Again, the label is the node that handles all of our text. If we go over here to the bottom and we go to custom fonts, we can go ahead and select empty and add in a new dynamic font. Now, as you can see, it actually removes the text. And the reason why it removes the text is because we don't have a font put in place. The way we do that is if we click on dynamic font again in custom fonts, remember we created that new dynamic font. If we click on it again, you could go ahead and access the font property. And in this font data, you could go ahead and drag any one of these fonts that we have provided for you in the assets. I believe I used the font title. So I'm going to go ahead and take font title and I'm going to go ahead and drag it into that. So now, as you can see, we have this new font title. You could also in the settings change the size of the font. So let's make it a bit bigger. I think 25 is a good size. So let's put it here. Excuse me. And then we're going to do the same thing for this thing right here. So do again. So custom fonts and fonts, click empty and click dynamic font. You're going to go ahead and go click on dynamic font again. And under the font tab for font data, just go ahead and drag font title onto there. All right. And then in the settings, let's make it a bit bigger. Let's do, I think 40 is pretty good. So the reason why it's not appearing is because I don't think this font has a specific has a texture for the pound symbol. So if we just change it to something else, like if I just change it to C, for example, that should change it. So let's go ahead and put it there. This panel is a lot bigger than I would like it to be. So we could just go to panel and we could just shrink it down a little bit. There you go. And we could just fix these up so that they're all nice and aligned. All right, I think I like the way that looks. So now if we go ahead and start the game, now the font looks a little better, looks less horrendous or ugly. All right.
Just an amusing thing that I've discovered. If you put the coin inside any of the tiles at all, then it thinks you've collected the coin.
Yes. So it counts. So these blocks, they count as physics bodies. So if you, for example, if you do that, it counts it as collected. So that reminds me, I do need to resize these coins because I do think they're a little too big. So we could just go back to coin and transform. We could go change the scale. Let's see. Let's change the scale to, let's try doing 0.5. Maybe that's a little too small. 0.5. Let's go ahead and hit save. There we go. I think that's a pretty reasonable size. So go ahead and add that. Add those wherever you like. Again, I'm just gonna go ahead and copy what I have for the level for the demo. I'm just gonna go ahead and copy where those are located. So there's one located here. There is one located around here, and then there's let's do this a little higher. And then there's one located around here somewhere. All right, so that's the level setup. So let's try to spice up our game a little bit. Let's say we want to add an animation that very clearly shows you that you have collected a coin. Because for now, all we're doing is, let's play this level a little bit. For now, all we're doing is when we collect a coin, for example. When we collect a coin, all it does is it disappears. So let's say we want to do something that looks a little bit better than that. What we can do is if we go to coin, we're going to go ahead and add another node to this. So we're going to go ahead and add an animation player. That one right there. We're going to hit create. So an animation player. So if anyone is familiar with video editing at all, for example, with Adobe Premiere, when you try to add your own text, for example, like if you're trying to make a video slide back and forth on the screen, you use these, you use the key marker tool, or I'm forgetting quite what it's actually called, but there's a key tool, the keyframe. There we go. Yeah, exactly. So it works the same way. So to make animations, we make them using the keyframes. So when you select animation player, it should bring up this animation tab here on the bottom. Under animation, go ahead and click it and select new. That way you can create a new animation. We're just going to call this collect for now. So with this animation player selected, we can now, as you can see, all of these little keys have now appeared next to our properties right here. So what we're going to change when we collect this key is we want it to grow bigger so that we could see that we collected it. We also want to slowly decrease its opacity from 1 to 0. So the way that we do that is, let's go ahead and select animated sprite. If we go to animated sprite, the keys actually disappear. The reason why they disappear is you need to make sure that the animation tab on the bottom is selected. That way the animation keys pop up right there. So under transform, we're going to go ahead and click this key right here. this creates a new track. Just go ahead and select create. Using this little slider right here, we're going to slide it all the way to the very end, so at 1 second. And then we're going to just, let's say we double the size, or we double the we double the scale of the thing. So go ahead and click the key again. And now if you just drag it back and forth, you can see it just grows in size. We're also going to go ahead and change the opacity. The way that we do that is if we go to visibility and we go over to modulate, go ahead and click the key for modulate so that you started at that 0 second. Go ahead and drag your slider all the way to the end. Click on that white bar next to modulate. Basically, all modulate does is it changes the color of the coin. What we're going to do, we're actually going to change its opacity. So we're going to make it from very visible to not visible at all. The way that we change that is we change the alpha value right here. So we're just going to drag it all the way down to 0. And it just basically disappears. It's completely transparent. And then we're going to go ahead and click modulate. So now if you drag it back and forth, it grows bigger and it also disappears. Something very important to note. If you drag this slider all the way to the end and you hit save, and then you play in your level, you'll actually see that you can't see any of them anymore. So if you play your scene, you can't see any of your coins anymore. That's because the animation player plays automatically at the wherever you have your slider at. So if your slider is at the very end, like it is here, and you play your scene, you'll notice that none of your coins are on the scene. They're still technically there. It's just they're completely transparent, so you can't see them. So the way to fix that is make sure you drag it all the way back to the beginning. So now if we go play here, now you can see the coins again. So let's just do a quick little test. So now if you collect one of these coins, I'll make him move a bit faster. He is a bit slowly moving right now. If you collect any of the coins, notice that you actually the animation doesn't play, and there's a very specific reason why the animation doesn't play. The reason is we are calling queue free as you collect the coin, and actually we haven't even called the animation player yet. So let's go here. In this, we're going to go ahead and do again. We're going to go ahead and call the child. So use $animation player. We're going to do dot play. And we're going to go ahead and play that collect right there. But the same problem will still arise. So if you look here, the same problem will still be there. So even if we're playing or calling the play method for the collect, as you can see, we're not actually seeing that animation. And the reason why we're seeing that animation is because the moment a physics body enters the area, it's going to call all of these methods, and queue free is called instantly, which means that the instance of this node disappears before it could even have a chance to play this collect button right here. The way we can amend that, the way that we can make sure that this animation plays before this disappears, is we can add a timer node. So what we can do, go to coin, select coin, press the plus button, and we can add in a timer. If I know how to spell, we could add in a timer. This timer is very simple, just wait. So if you go look here at the wait time, you could set how long you want this timer for be. So that's how long you could have it, or how short you could have it for now. Let's set it to 1 second. Auto start means that once you start the scene, the timer will just start going automatically. We don't want that on right now. So we just want that. We just want to keep it as is, basically. And what we do want from the timer is we actually want its signals. So if we come here, we want this timeout signal right here. So let's go ahead and double click it and add it to our coin scene. So let's click connect. So now we have this new on timer timeout function. So the way that we start the timer is if we come here, let's get rid of queue free actually. So let's press delete. Let's go ahead and access the timer. So $timer, and we're going to do dot start. And all this does is it starts the timer, and now the timer will start, and then when it times out, so when it reaches 0, it will call this function. And now when we call this function, that's when we could go ahead and put in the queue free option. Okay.
So would it be possible, with it set up this way, would it be possible for the player to pick up the coin while it's still, before it fades out.
Yes. So that is something that we do need to fix. But before that, let's just go ahead and make sure that that the coin animation does play. So yes, that is actually a one thing about this is technically if you move fast enough, let's go to our player so I could demonstrate this. So let's put our coin right here. And if I'm fast enough, if I do this and do this, if I do, let's set it a bit farther back. If I do this and do this, as you can see, I collected it twice. And the reason why that I collected it twice is because I'm still colliding with this collision shape right here. And a way that we can fix this is we can fix this using something called collision layers. In order to set up collision layers, we are going to go back to our project settings. We are going to go to project settings, and then we're going to go scroll all the way down to where it says physics. And we're going to go to, actually, it's not physics. It's this one, 2D physics. That's the different physics. So we're going to come here to 2D physics, and in these different layers, these are all of our different collision layers. So the way that we set them up is we can just go ahead and name them. For layer 1, let's go ahead and call it player. Layer 2, let's just go ahead and call these tiles. And for layer 3, let's just go ahead and call these coins. We can be, for the sake of time, we could, we're not going to be doing the spike ball object. But if you were interested in the spike ball object, that could be sort of your own implementation. The implementation of the spike ball object or the spike ball scene is very, very similar to how you implement the coin scene. So that could be your own personal project if you want to figure out how to add that in. So we have these collision masks, collision layers set up. So now if we come here, the way these work is if you come, let's go ahead and go to our player object. If you go to physics body 2D and you go to collision, you now have, you notice all these squares. And now if you hover over them, it has the names of the layers that we already specified just a little bit ago. So a good way to sort of explain the difference between a collision layer versus a collision mask is the layer tells Godot which scenes are on which layer, whereas a mask tells Godot which scenes can interact with which layer. So for example, for this player, we want Godot to consider this scene on the player layer. And then we want to tell Godot that this object in the player scene can interact with tiles and it can interact with coins. So we don't have any other players, so we can go ahead and select that off. And we can go ahead and click save. Now for coin, we could do the same thing. We could go to the coin area 2D and go to collision. So we are going to consider this layer. We actually don't need this to be on any specific layer. What we do need to do, though, is we need to make sure that we tell Godot that this object interacts with players or anything in the player layer of the collision mask. So we select in mask, we select the player, so bit 0 value 1, make sure it's selected there. What we're basically saying is when any physics body collides with this body, it will only collide with it and will only call any of these area functions only if that object that collides with it is on the player layer. The way that we amend that is by basically activating whether these masks are on or off. And the way that we do that is we come over here and we're going to call a function called set collision mask layer bit. So we're going to do mask and we're going to do 0 and we're going to set it to false. So this first parameter here is 0. If we go back to our coin scene, notice how when we hover over it says bit 0 value 1. It's basically, think of it as like an array. So bit 0 is for what's ever in index of 0, and then bit 1 is index of 1, bit 2 is index of 2, so on and so forth. So in this code, we're saying that whatever mask layer is in index of 0, we're going to set that to false instead of true. So we're going to go ahead and click save. We're going to go ahead and save this as well. So now we should have fixed our problem. So if we do this, we actually can't collect it again. So let me just play it again. And the reason why we can't collect it again is because we are basically setting this to false. So let's just say we start false in the beginning, right? And then if we play this, you'll notice that we actually can't collect it at all, because what we're telling Godot is that this object, this scene, can't interact with anything. And now when we do this, we're saying that this object can interact with things on the player layer. Player layer. All right, and now that should get rid of our problem of colliding with it twice. So that's how we sort of fix that using collision layers. Oops, and we're gonna go ahead and click save. All right, I think, let's see. For the purposes of time, the last thing that I will be talking about is sound, how to implement sound into your game. And it's really simple, actually. All you need to do is just add in this node called the audio stream player. So we're going to go here, we're going to click add, and we're going to go search up audio stream player. So there are different types of audio stream players. So audio stream player 3D plays spatial sound. So think of it compared stereo versus mono. 2D audio stream player will only play it in a certain direction. So if you select this, the audio might either come out of your the left headset or the right headset, or depending on where you want to do it. If you want the audio to just come out of all speakers, for example, just like in terms of mono or stereo, if you want the audio to just be mono, we're going to go ahead and collect just the normal audio stream player. We're going to select that. Let's just go ahead and just call this BGM for now. We're going to go ahead and select that. And in this stream section right here, we're going to go to our sounds and we're going to select bgm.ogg. Something that is very important when importing sound assets into Godot. Godot will only take OGG, and they will only take .wav files. So say they will not take in MP3 files or any other sound files. Again, they only take in .ogg and they only take in .wav. That's very important to remember. So we're going to take bgm.ogg and we're going to just drag it to stream right here. We are going to go and make sure we select autoplay. That way, when it plays in the, when we start the scene, it's just going to play automatically. So if we just do this, it's playing automatically. I don't think I have my sound shared, so you won't be able to hear it, but it is definitely playing. Here in volume dB, you could go ahead and adjust how loud it is. On my end, it's pretty loud, so I'm going to go ahead and adjust this. Instead of 0, I'm going to do -10. And then I'm going to go ahead and save it. Let's go ahead and play. All right, I think -10 is a pretty good, it's pretty good and is a pretty good volume level. One thing that we also need to double check is in this scene tab, if you see there's a tab right next to it called import, go ahead and select that. And you'll go ahead and see basically the elements of the sound file itself. So make sure in this BGM case, make sure that loop is on. If, for example, loop is turned off, make sure you click a loop on and click it on, and make sure you click re-import. If you don't click re-import, it will just keep the non-looped version of the sound in this player. So that's how you add BGM. So let's say you wanted to add a sound for the coin collecting. So if we come here, let's add one more node to this tree right here. We're going to do this, and we're going to add another audio stream player. Let's just go ahead and call this collect, if I know how to spell. We're going to go ahead and call this collect, and in the stream, we're going to go ahead and click this coin collect.ogg. All right, and then now in the player script, we're going to come here. Let's go ahead and we're going to do $collect. Again, we're calling the collect child node, and then we're going to just go play. All right, awesome. However, remember that we have to set the looping to off. So if I collect this coin, I know, actually, let me try sharing the, let's go ahead and play this. So I have this music playing in the background. Hopefully you guys can hear that. And watch what happens when I collect this coin right here. So as you can see, that noise actually loops a little bit. So if it wasn't for the fact that we had a timer that basically just gets rid of the instance, the sound of that collect.play that's playing right there, that sound would just loop forever. And the way that we fix that is if we go to, if we select the coin.ogg, like in the actual file system, and then we go ahead and go to import, make sure you have the loop turned off and then click re-import. I'm not exactly sure why, but it doesn't do it if you do it in here. So if you go to this scene and if you actually select this and do loop, for some reason, if you just do that, I don't think it will actually do it. We'll have to see. I think in my experience, it doesn't do it correctly if you just don't re-import it. Yeah, see, so it didn't loop that time, even though I have it selected as loop on here. I'm not exactly sure what that does. So just the way to fix the looping or the not looping is to just make sure you select the file that you have and then you click loop as off. And then make sure you click in re-import. Okay, and that's basically the whole game. Again, the last thing that you would need from this game is the spike balls that are in the demo. Again, that is up to you guys. If you guys can figure out how, using GD script, again, how to add in your, how to add that in. The other things you would need would be a game win scene or a game over scene. And again, it's the same thing as this demo that I did in the YouTube video. Again, very, very simple. Let's go ahead and play from the beginning. So if we do Penguin Ice game, if we go ahead and click play, it brings us here. Let's go ahead and play this game real quick. I think I messed it up a little bit. If I go back down here. He is moving a little bit slower than I would personally like, but we could go ahead and change that at any time. So it brings us back here. Again, if you want to have a game like a game win scene or a game over scene, it's the same. You make it the same way that you make this demo that I created here. Also, this collect is a little bit loud, so I'm going to go ahead and change that to -5 perhaps. Oopsie, I duplicated it on accident. But yeah, and then the same thing with the spike ball scene. The spike ball scene works in the same way as the coin scene and so on and so forth. If you guys would like, I actually have the original right here. So let me just show you what that looks like. So this is what the original game looks like. So I have this right here. Again, same thing as what you see in this demo for this scene. There's just a few less nodes in that one, but it's basically the same thing. I have this color rect, I have the label for the title, I have these buttons, and these buttons have 2 sounds in them. If you look at the script, if you do if you do pressed, it will do that, and then if you hover over it, it will play that sound. And then I emit a signal on this one. There's a signal called finished. So basically when that sound is finished playing, it will go ahead and change that scene. I have a panel right here, and then the how-to text, and then a text direct. Again, it's basically a little built upon version of the demo that I did for that YouTube video. If we go ahead and look at the player scene, it's the same thing that we did. So we have this and this. If you go ahead and look at that coin scene, let's see this coin scene. Again, it's the same thing that we've been working on. I will give you a sneak peek of what the spike ball scene looks like. So this is what the spike ball scene looks like. Instead of an area 2D like we did for this coin, we're actually going to be using a static body 2D. And the reason why we do a static body 2D is because we want the player to physically collide with the object, and when it physically collides with it, we want it to stop moving essentially. Just as a little hint, I have 2 collision shapes right here. I have a collision shape for for this one right here in the middle. This is for when the physics body collides with it, like physically collides with it, and it stops moving. And then I have another collision shape for this area 2D that determines that when you go inside it is a game over. So just as a hint, as if you want to implement your own spike ball, that is a hint that I have for you guys. And here's a little quick sneak peek of what the script looks like. Very, very simple. It's actually a little bit easier to implement this than it is to implement the coin. And then let's bring up level 1. Level 1 is also the same thing as we did in our game in today's workshop. The only difference is that I do have spike balls because I have implemented those. And then let's go ahead and take a look at the game over and the win scenes. So game over and win. So as you can see, very, very simple. It's the same concept as the demo screen and the title screen. The only difference I would say is that I do have sounds that I implemented here. So if I play this, if you hover, so when you get to the scene, it will automatically play that like a really sad jingle. And if you hover over this, it will like do a little quick little sound effect. If you click exit, it does that. And go have it play. So yeah, and it's the same thing for the win scene as well. The win scene, except instead of having 2 options, it has 1. And then you can go ahead and. So yeah, again, I implore you guys to work on the rest of this game in your own time. I have provided enough of the assets and also all of the coding and all of the concepts that you would need to build everything else. And not just this workshop, but also in the previous YouTube video. We can go ahead and link that in this YouTube video as well if you guys haven't seen it yet. But that's basically how to create that game from scratch. And again, all of these assets are provided if we want to go ahead and look. I have a note here. So all assets are from Kenny Game Assets 1 on itch.io. These assets are provided for educational purposes as part of the Godot workshop with the CPP Game Design and Development Club. If you like these assets and would like to see more from Kenny, please support him by donating or buying his products. So there's his social media, his itch, Twitter, Facebook, and website. So that's a little note that I left there. This is the actual license. So everything in this package is licensed, licensed Creative Commons, so on and so forth. All right. That's basically all I have for today's workshop. So just as a quick little overview, in a YouTube video, we talked about how to create your own title screen. In this video, we talked about how to create your player scene, how to make it move, how to use the project settings to change the window size, use the project settings to add collision layers, and use the project settings to add and create your own inputs. We learned how to utilize those inputs in a player script that we have right here and how to basically set up the player scene. I showed you guys how to create this very basic level, how to create your own tile map and how to set up the tiles for those. I showed you how to create a HUD that showed you how many coins you have and how many you've collected. And I showed you guys how to create a coin scene using the animated sprite and an animation player to play the collect animation. And also I showed you how to create this script right here that handles all of the animation playing and the sound playing. And I also showed you how to implement sound into your game. And also in the YouTube video, I show you how to import that game. I'll just go ahead and do it real quick. The way that you export. The way that you export your game is you go ahead and you go to project, you go to export. We have a preset right here. If you want to add your own preset, you could go to add and then select any of these presets right here. Because this is the same demo that we used in the YouTube video, the HTML is already here. When you do export path, what you need to do is you need to make sure you're in a empty folder. So let's create an empty folder, for example, new folder, and let's just do test. In this test folder, make sure you have the first thing you make is an index file. So you could go ahead and click save. And then you could go ahead and click export project. And then index HTML, save it, and then it already exports everything. So now if we exit out of here and we go to our tab right here, and then we go to this test folder that I already have set up, if you go there, then all of our stuff is already in there. All you need to do after this is just you need to get this. All you need to do is just send to and compress it. Once that's compressed, now you, oops, I accidentally put it in here. Once that's compressed, you now have these zip folder that you would use to upload to itch. And again, I already went over all of this in the YouTube video. All right. If there aren't any questions for anyone who's watching this via the YouTube video, go ahead and DM me on the Discord. I'm on the CPP game development channel as Sammy Mac or Sam M. Just go ahead and DM me if you guys have any questions.